those in video land, it is Friday, and we just opened. You didn't videotape her. We just this is almost Emily Martin's birthday. Oh. Emily number one. I just put her in danger. All right. So she is reaping the benefits. Show them this. Open this book. This is amazing.
What was I think it was this one that you showed? I don't know.
Yeah.
It's like really cool.
There's some pretty. She's gonna be working. Look at that one.
Whoa.
She's gonna be working on that for a while. So.
Oh no, my face is behind the camera. Now I'm gonna be in jeopardy.
Yeah, but how? To be honest, I don't think anyone else people at the school watched it.
All right, would you show her and him these problems? We're gonna pick up here. We actually graduated from the first torque worksheet to the second, and just show her the front right now.
This is number 2.
Yeah, that's good. Just do the front.
That's number 3. Okay.
Okay. All right, we're going to come back up to speed, remembering what we learned at in torque study. And you'll notice that this parallels number 1A. So if you would just bear with me and watch us go through this just to remind ourselves how torque works. There are two things that come to play when we're looking at torque. What are the two things? Alex, what times what is torque?
Mass times acceleration.
No mass, no acceleration.
It's a friction F parallel.
Yeah, what's F?
F is
not friction.
Force.
Right, force parallel. So it's not parallel. It's the opposite of parallel. What's that symbol? Perpendicular. Force perpendicular times
R
is the length of the lever, or as you like to say, the lever arm. Okay, so it's if we were creating a circle by this rotation, it would be the radius. It's more practically, it's the length of the object that is in rotation. So it's distance from the axis of rotation. So here we have a simple situation where we have a force applied here. Here's the axis of rotation. So it's going to cause a torque by putting 75 in here and 0.2 in here. So if you haven't started this one, this is 1A. Do you have one? I don't know if I gave you one. I guess I have to give him that one. This one. So, all right, is anyone not written on the back yet?
Of this one?
Yeah. All right, would you, because we're going to start writing, so show her the back, show him the back as well.
I need to zoom in a little bit.
Yeah. So when you multiply these two together,
What is the mass?
Emily, 3, what did you get for 1A?
15 newton meters.
Here's number 4. Number 5
Check
is...
that out, you'll see she is correct, and you will be as well. This is number 1A.
6.
75 is force perpendicular, and the radius is 0.2, and we come up with Newton meters as our unit. Newton meters. All right. Now let's look down at number 3. If you haven't got to that yet, this is 1A on this handout. This is number 3. So let's review. Some of you have already gotten there, and you can help us. Those who haven't gotten there can work it with us. All right, so I drew a picture of it. This is a meter stick. It's supposed to be uniform, and it's suspended at this point. So the axis of rotation is at this point right there. So we're going to find out what is the weight of this block. So there's a block hanging here with a mass. We want to know weight or mass. Weight in this problem. So number 3, they want to know the weight. There's a weight of 20 newtons hanging at the 80 centimeter mark, and we want to know what this would be. It is in balance. So let's set this one up. We know that when it's in equilibrium, the sum of the torques is 0. So we're going to add up all the torques and set it equal to 0. All right, Zach, I think you got this far. Did you yesterday? All right, so go ahead and tell me what is the torque created by this one.
But it's 0.3.
I'm sorry?
It's 30.
Are you giving me the answer?
No.
Okay, I'm just saying, where is it located? You're saying it's 30 away from?
Yeah, it's 30
all right.
away.
All right, so
you-
notice he got the distance from the axis of rotation is 30.
Sorry, that's
So-
40.
It is 10, 20, 30, 40. Okay, 40. It's 40 centimeters. So we're going to work in meters.
So yeah, so you
So we're going to put 0.4. You see where that came from? It's not, some people take the distance from the end, but remember it's from where it's suspended to the axis of rotation. So we got 10, 20, 30, 40 there.
And you say
All right, so wait a minute, and that is an unknown weight, I'll call it W. And we're gonna add up all the sum, that little symbol there means the sum of the torques, so,
And that's the 30, which is 0.3.
I'm sorry.
That's the 30, which is 0.3.
Okay, so what's the next,
And then it's 20 newtons.
how far away is this? 30 you said, so
Yeah,
0.3.
0.3, and then times
And it's
30.
20, sorry, I'm a little slow here. What are the signs? We have to mess with the signs of these torques. So if this one was free to move and this wasn't there, it would go that way. Would you review for me, is that a positive or negative
That's a
torque?
negative.
All right, it's going counterclockwise, see if I can do better today. So then I assume if this one was free to move, imagine it without being balanced by that, it would be going this way. So that's clockwise, so you have to always mess with the signs. And we decide, is there any other torques in this problem, Zach? Okay, so calculate that.
Then it comes out to 15.
15 newtons. All right, this is number 3.
So
Do you have any questions on how that was set up? If you do the math, you'll see that that is the correct answer. All right. What I want to do, because numbers 1B and what else is on the front there? 1B and number 2 are pretty much reflections of this information and nothing new. And number 4 is also. But when we get to number 5, we hit, and number 6 is easy peasy too. Number 6 is one of these. So, let's do number 5 together, then I'll release you to finish this sheet, and if you are finished, I have 2 more problems for you to do. Alright, so the difference on number 5 is I'm going to teach you a new aspect of this. So far, we have, do you have this down? Can I erase it? Do you have number 1, A, and 3 if you needed it? Do you have it? Number 3? Looks like you do. Did you get it all the way? Yep. Alright, I can erase. Alright.